Good afternoon, everybody. Welcome to IS. Today we continue our differentiation series. Please, if you know that you are new to this channel, please kindly like and press the notification button so that you get notified when next we post new video. So before our previous video, we treated on different function. First, the polynomial function and the product function. Today we're diving on the quotient function. To get better understanding, please visit our former video for understanding on the concept of differentiation. Today, we'll be diving on quotient function. Today, I will tell you the ways and the pattern in which we solve quotient questions. Maybe if you come across them, maybe in an exam or test, as the case may be. Now, remember, quotient function, product function, they are kind of the same. The difference is displayed on the board. Now, y equals, which is this one now, y equals u all over v. Remember our product function, it is y equals to uv. So the difference between the quotient and the product function is, okay, this one is for the product, where y equals to uv is for the quotient. So where u and v are function of x, so that's the difference between quotient of product function. Now with the general formula, so this is the general formula for quotient function. dy dx equals v du dx minus u dv dx all over v squared. So that's the formula for quotient function. You know that. And now questions. Let's solve question pertaining to this formula displayed on the board now. Questions. Find dy dx of the following functions. You see, find dy dx of the following question. Question 1, 6 plus 7x all over 4 minus x. Question 2, the same. Question 3, the same. Now we are going to use this formula now to solve the questions displayed on the board. Now, solving question 1. Question 1 now. Y equals u all over v. Remember, this is for quotient function. Now the question is y equals 6 plus 7x all over 4 minus x. Remember, our numerator, the upper one is our u, while the denominator is the v. Now the u, which is this one, 6 plus 7x, while the v, which is the denominator, right? V equals 4 minus x. Now differentiate the u now, which is the du dx, right? Differentiation of u with respect to x. The u dx equals 7. Differentiate this one, which is a constant, it will give you 0. Differentiate this one, 7x. This one now is the variable, right? While this one, 7, is the coefficient of x. Now differentiating the 7x will give you 7. While the v, which is at the denominator, 4 minus x. Remember, right? Differentiating the v, which is the v dx. The v dx equals, now differentiating the constant, which is the 4, will give you 0. Differentiating minus x, which will give you minus 1. Now, the general formula displayed on the board, which is the dy dx, equals v du dx minus u dv dx all over v squared. Now, dy dx equals, now, where is our v, which is the v here, right? Our v is 4 minus x, the 4 minus x here. Our du dx, which is our du dx now, the 7, brought it down here. Now, the negative side remains the same, which is our minus sign. So now, the u, where's our u? Our u is 6 plus 7x. That's our 6 plus 7x here. While the dv dx, our dv dx is minus 1. This is our minus 1 here. All over v squared, which is the denominator. This is 4 minus x. 4 minus x is about 2. This is the square we have here. Now, dy dx equals, at this place, we will open the bracket by using the first bracket to multiply the second bracket. Well, I try to expatiate at this place. Now, use the 7, right? This 7 to multiply this 4. 7 times 4 will give you 28. Don't forget that. Now, 7 times minus x will give you minus 7x. Okay, we are through with that one. Remember, there's a minus sign here, right? So, if I use this, we first of all use this sign, minus sign, to open the bracket. Now, 6 minus times 6 will give you minus 6, right? Minus times plus will give you minus. So this will now be minus 7x. So now we now have minus 6x minus 7x. Minus 1 times minus 6x we give you plus 6. We give you plus 6, right? Now, why the minus 1 times the minus 7 we got here? We to give you plus 7x all over the denominator, bracket open 4 minus x is a part 2. So that is how we explicate this thing. Before we continue, we must first explicate this bracket to give us, they'll have the simplified version of this one. So this one is the simplified version of this one now. That is how we do this one. Now, divide dx. Now, divide dx equals 28 minus 7x plus 6 plus 7x all over the denominator here squared 4 minus x bracket open and close this part 2. Now, divide dx equals, here now we call it like terms. This one and this one, they are alike, right? Why this one they are alike? So now 28 plus 6 will give you 34, right? Now minus 7x plus 7x will give you 0. That is how we got our 34 here. Now divide dx equals to 34 all over the denominator. I told you before, when dealing with quotient function, we don't expand the denominator. We leave it like that. We only pay reference to the numerator. Let's take question number 2. Now, question number 2. Y equals x squared 3 plus 6x plus 9 all over x squared plus 5x plus 1. Now, remember, the formula is y equals u all over v. So we'll take this as our u, y this one as our v. Now this is our u, the one at the numerator, y the one at the denominator is our v. Now diversity u with respect to x, so the u dx equals diversity x squared to give you 3x squared. Diversity 6x will give you 6, y diversity y 9, which is a constant, to give you 0. The v, which is the one at the denominator, diversity v with respect to x, the v dx equals x squared will give you 2x, alright, and 5x will give you 5, 1, 0. Usually the formula divide the x v, the u dx minus u dv dx all over v squared. We have divide dx equals our v, which is this one, put it here, our du dx, which is this one, put it here, the minus sign is to be here, right? U, which is this one, put it here, the v dx, which is 2x plus 5, put it here, all over v squared, which is this one, which is part 2. Now divide dx, we trying to expand this bracket by multiplying the brackets together. Divide dx, now we use this bracket to multiply this one, while we use this one to multiply this one. That's how we go about problems like this. Now 3x to the power 2 multiplied by x squared give you 3x to the power 4, while 3x squared multiplied by 5x will give you 15x to the power 3. 3x to the power 2 multiplied by 1 will give you 3x squared. Now using this one, which is the 6th part of it, 6 times x squared will give you 6x squared. 6 times 5x will give you 30x. 6 times 1 will give you 6. Now the negative sign. We use this bracket to multiply this one as well, which we did for the first one. 2x multiplied by x to the power 3 will give you 2x to the power 4. 2x multiplied by 6x will give you 12x to the power 2. 2x multiplied by 9 will give you 18x. Now the 5 part of it, 5 multiplied by x squared to the power 3 will give you 5x squared to the power 3. The 5 times 6x will give you 30x, while the 5 times 9 will give you 45. Now remember that's inside bracket. We use the negative sign to go through the bracket. We use this negative sign to go through the bracket. Now doing that, we repeat this one here, 3x to the power 4 plus 15x to the power 3 as we got here, plus 3x to the power 2 plus 6x to the power 2 plus 30x plus 6 as we got here. Now getting to this side now, the negative sign times this one give you this one negative 2x to the power 4. Negative sign times this one will give you negative 12x to the power 2. Negative sign times this one will give you negative 18x. Negative sign times this one will give you minus 5 raised to the power 3. Negative sign times this one will give you minus 30x. And the negative sign times this one will give you negative 45 all over the v squared, which is this one. X raised to the power 2 plus 5x plus 1 bracket close all to the power of 2. Now divide the x equals here. Now we call it like terms. We call it like terms. We have 3x raised to the power 4, right? This is also raised to the power of 4. So we merge them together because they have the same power. We have the 3 and the 2. Okay, after 3 now we remove the after 4 we remove the 3, which is this one, the 15, positive 15, 15x raised to the power 3. We have again, which is the 5, negative 5x raised to the power 3. So we merge them together because they have the same power. So this have the same power, right? So this as well have the same power. Now move from 3 to 2. Plus 3 plus 2, right? 3x raised to the power 2. We have plus 6x raised to the power 2, and we have minus negative 12 raised to the power of 2. That's right. Now moving to x, we have 30, positive 30x, right? Which is this one here. We have negative 30, which is this one, and negative 18, which is this one as well. Okay. Moving to the one without x, we have 6. This is this one, positive 6, right? And negative 45 all over v squared, which is this one. So this one now raised to the power of 2 is the one at the denominator. Now divide the x equals 3x raised to the power 4 minus 2x raised to the power 4. 3 minus 2 given 1, which leads us to this one, x raised to the power 4, right? Plus 15 x raised to the power 3 minus 5x raised to the power 3 give us 10x raised to the power 3, right? Now 3x raised to the power 2 plus 6x raised to the power 2 minus 12x raised to the power 2 will give us minus 3x raised to the power 2, because the negative side is going alongside with the 12. Do you understand? So that is it. Now add this one together will give you 9, right? So 9 minus 12 give you minus 3. That's how we got to this one. The x is equal to 3. Now moving from there, we have this one, right? 30 minus 30, nothing, 0. Now leave us with minus 18x. That's how we got our minus 18x here. Now the negative sign goes to this 45. So now positive 6 minus negative 45 will give us minus 39 all over the denominator, which is x squared plus 5x plus 1 bracket open and close to the power of 2. So that is that for this one. Now moving to question 3. Question 3, y equals x plus 8 all over x plus 9. Remember our formula where y equals u all over v. So this one now is our u, while this one now is our v. That is it. Now our u here and our v here. Differentiating this one with respect to x. So the u dx give us 1. Differentiating x will give us 1. While the 8 is 0. This constant is always 0. Now the v perspective, x plus 9, differentiating x differentiating v with respect to x will give us the v dx all over 1 as well. Now applying the formula, the y dx equals v du dx minus u dv dx all over v squared. The y dx equals, where is our v? Our v is x plus 9, which is this one. Our du dx is 1 multiplied by 1, right? The sign, which is negative sign. Where is our u? Our u is x plus 8. What we have here? Our dv dx, which is 1. How got this one here? All over the v squared, which is the one, the denominator. This one squared. X plus 9 raised to the power of 2. The y dx equals, use this x bracket open x plus 9 bracket close bracket open 1. So we use this bracket now to multiply this one, and as well use this one to multiply this one. So 1 times x will give us x, right? 1 times 1 times 9 give us 9. Now 1 times x will give you x, right? 1 times 8 will give you 8. We give you the same, right? 1 times x will give you x, 1 times 8 will give you 8. Now we use the negative sign, which is this negative sign, to go through the x and the 8, which will give you negative x and negative 8. This is how we got this one here, because after opening the bracket, we now use the negative sign to go through the x and the 8. That's how we got negative x and negative 8 all over v squared, which is x plus 9 raised to the power of 2. dy dx equals, now we collect like terms. Then you collect like terms. So you have positive x and negative x, right? X minus x, where we have 9 and negative 8. X minus x plus 9 minus 8. So now, since it's x minus x, this x cancel out this x because it's minusing. While this 9 minus 8 will give us 1 all over x plus 9 raised to the power of 2. dy dx equals 9 minus 8 will give us 1 all over the denominator x plus 9 to the power of 2. So that is this for this one. Moving to question 4. Now, question number 4. See, this question contains trig, the 7 sin x and the 8 cos x all over 7 plus 8 exponential x. It contains trig and exponential. So now, remember that our numerator is our u, while the denominator is our v. The u, which is the 7 sin x plus 8 cos x. Differentiate the u respect to x, give you the u dx. Differentiate this one. Remember our normal differentiation. Sin x, you give us minus, you give us cos s. Remember, y cos s, you give us minus sin x. So we'll be using this one in this. Now, differentiate 7 sin x give you 7 cos s. Remember, sin x give you cos s. So since you are differentiating 7 sin x, it give you 7 cos x plus now 8 cos s. Remember, differentiating cos will give you minus sin x, right? 8 cos s will give you 8 minus 8 sin x. That is for the numerator, which is the u. While for the v which is 7 plus 8 exponential x. Differentiating v respect to x, right? dv dx equals, remember 7 is our constant, which is 0. Differentiating 8 exponential x. Remember, like just like the 8 exponential x. Break down our function, which is the power down, which is the x. Differentiating this one, right? This x will give you 1 times the coefficient, which is the 8. Rewriting this thing, what is differentiated, the exponential x. Now, 1 times this will give you 8 exponential x. 8 times exponential x will give you 8 exponential x. That's how we got this one here. So, differentiating 8 exponential x will still give you 8 exponential x. Now, using the formula dy dx equals v du all over dx minus u dv all over dx all over v squared. Dy dx equals our v. What is our v? Our v, which is 7 plus 8 exponential x. 7 plus 8 exponential x. What is our du dx? Our du dx is 7 cos x minus 8 sin x. 7 cos x minus 8 sin x, right? Minus the negative sign, repeat it here. Is our u. Our u is 7 sin x plus 8 cos s. 7 sin x plus 8 cos s. Our dv dx is 8 exponential x, 8 exponential x all over v squared, which is the 7 plus 8 exponential x raised to power 2. Divide the x equals, now we use this one, the first bracket to multiply the second bracket, which is 7 times 7 cos x will give you 49 cos x. 7 times minus 8 sin x will give us minus 56 sin x, right? Now, we use the 8 exponential x to multiply 7 cos x will give us positive 8 exponential x, 7 cos x. Now, using the 8 exponential x to multiply negative 8 sin x will give us negative 8 exponential x, 8 sin x. Now, repeating the negative sign here, right? Now, 88, this one, use this one, I swear to multiply this one. 8 exponential x multiplied by 7 sin x will give us 8 exponential x, 7 sin x. And 8 exponential x multiplied by 8 cos x will give us 8 exponential x, 8 cos x, all over the v square, which is the 7 plus 8 exponential x raised to the power of 2. I got this one. Now, dy dx, we use this negative sign to multiply through this bracket. Now, 8 times negative sign times 8 exponential x will give us negative 8 exponential x, right? Now, negative, this minus a negative sign, multiply this positive 8 exponential x, 8 cos x, which will give us negative 8 exponential x cos x all over 7 plus 8 exponential x raised to the power of 2. Dy dx, now we collect like terms. So now, starting from 49 cos x, this is the only cos x in this place, so trying to repeat it, 49 cos x. Now moving to the sin x, minus 56 sin x. This is the only sin x in this place at the numerator now. We tend to repeat it here, 56 sin x. Now, imagine that 8 exponential x, 7 cos x, we say have exponential x cos x here, which is minus 8 exponential x cos x. So this one are like, we tend to put them in the same place, which is 8 exponential x, 7x, 7 cos x, and minus 8 exponential x cos x. This one are like, we also have negative 8 exponential x, 8 sin x, and negative 8 exponential x, 7 sin x. So this one, they are the same. So place them in the same place. Negative 8 exponential x, 8 sin x, negative 8 exponential x, 7 sin x, all over the 7 plus 8 exponential x raised to the power of 2. So this is it for you. This is our final answer for this question. Now, moving to question 5. Y equals sine all over cos. This is another trick question. Remember, this is our u and this is our v. U, which is the sin x, right? Now, differentiating u respect to x, du dx equals, I told you before, sin x is cos, give you cos x. When differentiating sin x, to give you cos x. Now, the v equals the which is this one, the cos, right? Now, differentiating the v respect to x, the v dx equals, differentiating cos will give you minus sin x. Using the formula, dy dx equals v du dx minus u dv dx all over v squared. Have dy dx equals, where is our v? Our v is cos, which is the cos we have here. Where our du dx is cos as well, because we have here, tend to bracket them, so you can easily differentiate both. We have repeat negative sign, which is this one. Now, where is our u? Our u is sine, right? Sine, and our dv dx is minus sign, right? The minus sign here, all over the v square, which is the cos, right? Bracket open and close, raised to the second power. Dy dx. Now, multiplying these two brackets together, cos x times cos x, will give you cos square x plus minus sin x times minus sin x will give you positive sine squared x all over cos x raised to the power of 2. Note MB that cos squared x plus sine square s equals 1. This is a law in trig. So now since this one will give us 1, therefore the y dx equals 1 all over cos x raised to the power of 2. So that is all for this one. This is now our final answer. If you have any question related to this one, please, I would like you to drop it at the comment section. We will do justice to it. So any question at all, anything you want to, any question at all, we will be there to respond to you. So thank you. Please subscribe to support our channel. Thank you.